So today we're going to start logarithms. And I know a lot of you guys don't like logarithms, or whatever you've learned from logarithms, you heard they're hard, or etc. So I'm going to teach you the three basics type of logarithms. And if you can master these, then all the other parts should be a little simpler. So let's see what a logarithm is. Logarithms are exponents, but written with the word log. So this says log base 2 of 32 is equal to 5, right? Another way to write this would be 2 to the 5th power is equal to 32. 2 to the 5th power is equal to 32. They're equivalent to each other. They're actually inverses of each other. Let's look at our box over here. Logarithms. Y is equal to log base b of x if and only if b to the y power is equal to x. This is a definition. Anytime you have if and only if, that is a definition. And so this is saying that these two are exactly the same. And notice how I matched them up with the colors. Our base is always going to be the base of our logarithm. Our answers are always going to be our exponent. And for over here, and then this x is always going to be our answer. Okay? So, if we look over here, this is our logarithm, this is our base, this is our argument, okay? And we know that our base can't be negative and our argument can't be negative because there's no way that I'm going to be able to raise this base to an exponent and it's going to come out as a negative answer. Even if y is negative, for example, 2 to the negative first power is not going to be negative 2, it's going to be 1/2. So there's no way that this can ever be negative. And the base, we know based off of our exponents notes that we did the other day that this cannot be negative. We can have a negative out front and that's a reflection, but we can't actually have a negative base. Okay, so copy this information down. And let's look at some examples. Okay. So we want to change the logs to exponent forms. So what is the base for this one over here? It's a base 3. What is our exponent? That's negative 4, and that's equal to x. Okay. Over here, what's our base? That's the 2. Our exponent is the x, and this is equal to 8. And notice this is something that we did the last time you guys had notes, where you got to change the base to the same in order to solve for it. So we've done some of this already. Over here, our base is x, our exponent is 2/3, and our answer, which is our logarithm, is going to be 4. Okay, even though this doesn't have equal to x, that's what it means. Whenever you don't see it equaling to anything, you know automatically it's equal to x. Okay, so we can rewrite this as log base 4 of 16 is equal to x. These are both the same thing. Our base is 4, our exponent is x. This is equal to 16. Okay, so that's how we change a logarithm into an exponent. Let's look at this last little part. So whenever you see log of x, you notice that there's no base there, right? You automatically assume it's log base 10. And if you look on your calculator, you have just the log key. That's a log base 10, okay? We don't need to write the 10 there because it's automatically assumed that it's a base 10, okay? So now that we know the basics of how to change a logarithm into an exponent, let's look at how do we solve them. And we have 3 different types of logarithm problems. These are the 3 basic types, okay? So, if I have log base 3 of x is equal to negative 4, the first thing I'm going to do is change the problem to exponent form. You're always going to change it to exponent form, and then we're going to solve it. So in this case, what is our base? That's 3. Our exponent, negative 4, and this is equal to x. And this is pretty easy, right? We can just type into our calculator 3, hit our caret key, negative 4 as our exponent, and press enter. And then of course I want it in fraction form. I press math, enter, and apparently it does not give me a Does not give me a fraction. I'm not sure why. But this would be 1 over 3 to the 4th power. And then I can do 1 over, so this is 3 times 3 times 3 times 3, which gives me, let's do 3 times 3 times 3 times 3, or 3 to the 4th, and I get 1 over 81. So that fraction should have been 1 over 81. I'm not sure why the calculator didn't do that for me. But this is probably the easiest of the logarithms, is when we're solving for x, and x happens to be our argument. Okay? So we're finding the argument. So over here, give these two problems a try. You can pause the video and try it. Okay, so for A, our base is 3, our exponent is 2, and that's equal to x. What's 3 squared? Which is 9. So x is equal to 9. Done. Over here, we have 1/2, right, as our base, and 7 is our exponent. So we have x is equal to, what's 2 to the 7th power? We get 128, so this is 1 over 128. I basically did 2 to the 7th power, which is 128. 1 to the 7th power is still 1. Okay? Now, let's look at solving for the logarithm. The logarithm, once again, is our y. Okay? Let's look at this part. So, we're going to find the logarithm. Log base 2 of 8 is equal to x. Also can be written as log base 2 of 8 without the equal sign, right? So the first thing I'm going to do is change the problem to exponent form. What is my base? That is a 2. What is my exponent? That's x, and this is equal to 8. And we actually did this on the last set of notes, where we want the bases to be the same, okay? Can I make 8 into a base 2? Yes, that's 2 to the 3rd power. And now that the bases are exactly the same, can we ignore our base? Yes. And so now x is equal to 3. There's nothing else to solve. It's just equal to 3. Making sense? So why don't you give these 3 problems a shot? Okay, so at this point, just pause your video and go ahead and start those problems. I'm going to go ahead and go over them now. So this is a base 3. Our exponent is x, and this is equal to 81. Now, even though it doesn't say equal to x, we know that it is equal to x. Okay? And 81, we can do that as a base 3. So 3 to the x is equal to 3 to the 4th power. So x is equal to 4. Okay? So for the next one, we have a base of 5. And our exponent is x, and this is equal to 1 over 625. First off, it's a fraction. Let's go ahead and make this into a whole number by moving it above the fraction bar. So I have 5 to the x power is equal to 625 to the negative 1st power. Because if I move it above or below the fraction bar, right, I have to change the exponent to a negative. So now let's look at this as a base 5. 625 is a base 5. Can I do that? Let's see. 5 times 5 times 5 gives me 125. If I multiply by 5 again, I get 625. So now I have 5 to the x power is equal to 5 to the 4th power, and we still have that negative 1st, right? So 5x is equal to 5 to the negative 4. X is equal to negative 4. Making sense? Okay, now let's look at this last one over here. I have 1/2 to the x power, and that's equal to 8, right? Well, let's make this into a whole number, and I move it above the fraction bar, and I have 2 to the negative 1st raised to the x power. And can I change this into a base 2? I can. That's 2 to the 3rd power. So negative 1 times x is negative x is equal to 3. I divide both sides by negative 1, and x is equal to negative 3. Okay? Now for the final way to solve for a logarithm. This is if we're solving for the base. Okay, so over here, once again, I have my base. I have to change to exponent form. My base is x. My exponent is 2/3, and that's equal to 4. Now, anytime we are trying to get rid of an exponent, right, and in this case we are because we want x by itself, then I have to multiply by the reciprocal of whatever that exponent is. So x 2/3 is equal to 4. What is my reciprocal of 2/3? That's 3/2. Okay, so 3/2 over here. 2/3 times 3/2 is 1. And I have 4 to the 3/2. And I can just plug this into my calculator and see if I get an answer. This is basically saying the square root of 4 and then cube it, right? Or 4 cubed and then take the square root of it. Same thing. Let's see if I can get an exact answer. I do 4, raise it to the 3 divided by 2, and I get 8. And if we look at it, the square root of 4 is 2 to the 3rd power is 8. 4 cubed is a big number. If I take the square root of that, it's probably 64. Then the square root of that is 8. So 8 is my answer. Okay? So, try these 3 problems. Okay, you can pause the video and go ahead and try these 3 problems and copy down those notes. Let's go ahead and take a look at this. For here we have x to the -4th power, and that is equal to 16. So in order to get rid of that -4th power as an exponent, I have to multiply by 1 over -4. And then I have to multiply this, raise this up to the 1 to the -4th power. So here we get x is equal to, and I'm just going to type in 16 caret key -1 divided by 4, which basically means what's the 4th root of 16, and that says 0.5, so that is 1/2 is my answer. All right, we can use our calculators. That is not a problem. So over here we have x to the 3rd power is equal to 1 over 8. So once again, I have to multiply by the reciprocal of 3, which is 1/3. So raise this to the 1/3 power. Here I get x, and 1/8 to the 1/3 power. Let's see what that is. 1 divided by 8. Actually, do that in parentheses. Parentheses 1 divided by 8. Okay, and then raise that to the 1 divided by 3 power. And that gives me 0.5, which is 1/2. Don't give me decimals. Okay? That's 1/2. And then this last one, we have x to the 3/4 power is equal to 64. And what is my reciprocal of 3/4? It is 4/3. Right? And so I'm going to do 64 raised to the 4 divided by 3, and that gives me 256. Okay, so your calculators are going to come in handy for these, unless you want to do them manually, and you can do them, they're not that hard. But we have calculators, so hopefully you'll know how to use your calculator. So the last little bit is a natural logarithm, right? A logarithm with a base of e and uses the symbol ln is a natural logarithm. So, for example, y equals ln x is the same thing as log base e of x. I always change them back to log base e of x because personally I need to see that e in order to remind myself that that is the base of this, but then we can change this to e to the y power is equal to x, which is right here. Okay, so, for example, ln of 3 is the same thing as 3 is equal to e to the x power, or log base e of 3, which is e to the x is equal to 3. Okay, so if you see an ln, don't be afraid, just change it to log base e of 3 if that makes you feel better, and then you can solve for it. So this is all the notes for basic logarithms. You have 3 basic types. Hopefully this will make sense to you. If not, make sure you're going to the Rose Lab, or you are going to see Mr. Bethel in room 237, or you can even text me, although I can't guarantee that I will always answer, especially if I'm still recovering. So good luck.